This video is about solving radical equations. That means an equation that contains a radical. In this first video, we are going to be solving equations with only one radical. So, the steps to solving an equation with radicals is first you have to isolate it, just like we did with absolute value equations. Get that radical by itself on one side of the equation. Then you're going to raise each side of the equation to the power equal to the index of each radical. So for example, this is a square root. To undo that square root, we would square both sides of the equation. If there's more than one radical, you would repeat those steps until the radicals are gone, and then you have to check your solutions. So notice here I have it all capitalized, because with radicals, it's very easy to get what we call an extraneous solution. That means it looks like a solution, it walks like a solution, but it's not a solution. So you have to check your answers. Alright, this first example on the left. I have the radical by itself. There's stuff underneath the radical, but there's nothing else being added, subtracted, multiplied, divided to that radical. So it's all by itself, equaling to a constant. So once that's isolated, we undo the square root. So I'm going to undo that square root by squaring both sides of the equation. When I square a square root, I'm left with what's underneath the radical. So 3x minus 2. Because that square and square root undo each other. On the right hand side, I have 4 squared. 4 times 4 is 16. Now I have no radical, I have a linear equation. So I just solve by getting x alone. Add 2 to both sides. I have 3x equals 18. Divide both sides by 3 to undo that multiplication. And x equals 6. Again, you have to check your solutions to make sure that they really work. So over here, I'm going to just do some side work to check. So I have the square root of replacing x with 6 minus 2 equaling 4. I want to see if this makes a true statement or not. So that's the question. Are these really equal? Well, 3 times 6 is 18. 18 minus 2 is 16. Does the square of 16 equal 4? Yes, that is true. So this is our solution. Go ahead and try the example on the right-hand side. The example on the right-hand side, the radical is not isolated yet. So before I can do anything else, I need to add 8 to both sides of that equation. Now I have the square root of 3p minus 18 equaling 18. Now that it's isolated, I can undo the square root. So I'm going to undo the square root by squaring both sides of that equation. The square of the square root 3p minus 18, that square and square root undo each other, and we have 3p minus 18 equaling 18 times 18, which is 324. And now we need to get p alone, because now we have a linear equation. I'm going to add 18 to both sides. I have 3p equals 342 now. And then divide both sides by 3 and get, let's see, divide by 3, 114. And then of course we can check. So I'm going to go ahead and just pull up a calculator here and show you. So we're replacing p with 114. So we plug in p, 114 times 3 is underneath the radical. and then we would subtract 18. Now we have 324. We need to take the square root of that. We get 18, and then we can subtract 8. And does that equal 10? Yes, it did. So that one checks out as well. All right, let's look at some more examples. Next example, I have the square root of 9x minus 2 minus 2x equaling 0. First step, isolate that radical. So I'm going to start by adding 2x to both sides of the equation. That's gone. Now we have the radical alone. 9x minus 2 equals 2x. Now I want to undo the square root. So I've isolated it. Now I can undo it. I need to square both sides of my equation. When I square a square root, they undo each other, and I'm left with 9x minus 2 on the left-hand side. On the right-hand side, I have to square 2x. So 2x times 2x will give me 4x squared, right? 2 times 2, x times x. Now I have a quadratic equation. So I have an x squared here. Unlike the other ones, I had linear equations. I need to get x alone. With a quadratic equation, I need to get everything on one side and try to factor. So I'm going to move the 9x and the 2 over to the right-hand side, right? I want to keep that x squared positive. So I get rid of those. Now it's 0 equals 4x squared minus 9x plus 2. With quadratic equations, remember, we get everything on one side, try to factor. So to factor this, I notice that the leading term here has a coefficient that's not 1. We need to multiply 4 times 2 and get 8. So I need factors of 8 that will add to negative 9. So I'm thinking negative 1 and negative 8. Those will add to negative 9, but multiply to a positive 8. So I factor 4x squared minus 8x minus 1x plus 2. Again, that leading term was not a 1, so we have to factor by grouping. I can pull out a 4x on the first two terms. When I pull that out, I'm left with x minus 2. On the second two terms, I notice it goes minus 1 plus 2, but I need it to match the x minus 2. So I'm going to go ahead and take out a negative 1 here. That'll change my negative x to positive x, my positive 2 to a negative 2. Now they match. I can take out that GCF of x minus 2, which would leave me with 4x minus 1. We set each one of those factors equal to 0. So x minus 2 could be 0, which means x would be 2. Or 4x minus 1 could be 0, in which case we would add the 1, divide by the 4, and x could be 1/4. Now I have already checked those, and they both work. But remember, you need to keep checking all your solutions because you could get an extraneous solution. Go ahead and try the problem on the right, and be careful when you square that side, that right-hand side. Okay, I want you to think about that. Let's see how you did. So first step, isolate the radical. Done. It's already alone on one side of the equation. Second step, undo that square root by squaring both sides of the equation. Now, question is, how did you square that right-hand side of the equation? If you wrote x squared plus 9, you made a fatal mistake. You cannot distribute exponents across sums and differences. Don't do that. You need to either use the box method or FOIL it out, right? So x plus 3 times itself. You're squaring it, that whole quantity. So x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. So there's 4 terms here. When you multiply 2 by 2, there's 4 terms that you end up with. We add our like terms. 3x plus 3x is 6x, and plus that 9. So that is the right-hand side when you square x plus 3. You have to remember to multiply by itself and either box or FOIL it. Okay, on the left-hand side we have squared a square root, and we're left with just 9 plus x. We look at the result and decide where to go from here. It's not linear, so I need to get everything on one side, try to factor. I'm going to subtract 9 from both sides of the equation, subtract an x from both sides of the equation. So the left-hand side is now 0. The right-hand side, I take 6x minus 1x and get 5x. And positive 9 minus 9 gives me 0. It's just gone. The goal was to get everything on one side, so set it equal to 0, and then factor. There's only 2 terms here. They're not a difference of squares or some are difference of cubes, but I do see a GCF. So I take out an x, and I divide out an x I'm left with, x plus 5. So now I have 2 factors. I set each factor equal to 0. This x is a factor, okay? So I set x equal to 0 and x plus 5 equal to 0, which means x could be 0 or x could be negative 5. Next question, did you check your solutions? Okay, that's important. I'm going to check them. If I plug in 0 first, I have 9 plus 0 under the radical equals 0 plus 3. Well, that's gone. It's just 0. Square root of 9 is 3, and 0 plus 3 is 3. That checks out. 0 is part of our solution set. Try negative 5. Take the square root of 9 plus a negative 5 equals negative 5 plus 3. Well, 9 plus a negative 5 is 4. Square root of 4 is 2. On the right-hand side, negative 5 plus 3 is a negative 2. Does positive 2 equal negative 2? No, those are not equal. So this is not part of our solution set. It didn't work. Now that has nothing to do with the fact that it's negative, okay? You can have negative values of x, but in this case it turned out to be an extraneous solution, and the only solution is x equals 0. Make sure you are checking your final answers.